From this to this. In the developing world, cassava is a crucial ingredient in so many products such as flour, porridge, beer, hand sanitizer, and even reusable plastic wrapping. And it's a staple source of food for millions of people. But it's very vulnerable to disease. On the left is healthy cassava that can be eaten or processed. On the right, another ruined crop blighted by disease. I'm Professor John Colvin from the Natural Resources Institute, and I want to tell you about the African Cassava Whitefly Project. There's lots of different species of whitefly, but the one we're particularly interested in is called African Cassava Whitefly. And it's a very, very tiny insect, but it's hugely damaging, both as a direct pest, because it literally sucks the nutrients out of the plant, and also because it's a vector of plant diseases that cause huge economic losses across Africa.
My name is Oyonga Frederick Charles. This is my farm. Whiteflies is one of the pests that we have identified as a bad pest that can spoil the cassava in two ways. One, internally and externally. Externally, it spoils the leaves and even sometimes makes the plant look stunted, get stunted growth. Internally, it can spoil the root, which is really what we want, is the root part of it. And now when the root is spoiled, we get famine. Now when whiteflies are there, a great number of whiteflies are there in the garden, it means they lost to the farmer.
The losses can be extremely serious. In the 90s, this little insect transmitted what was called a severe strain of cassava mosaic virus, and that literally killed the plants, killed the cassava, and it resulted in famine and food insecurity across much of Uganda.
I'm Dr. Omongo Christopher. This project really came from the farmers' lack of knowledge of what is happening in their cassava. Before this project started, the biggest problem which the farmers were facing in their cassava was actually cassava mosaic disease. The problem of the mosaic started moving from one location to very many locations because of the mobility of the whitefly. So the farmers' problem actually multiplied with more whiteflies coming into existence and transmitting this mosaic.
They saw a difference in their cassava, and they saw the symptoms of the mosaic disease, the stunted plants, the chlorosis in the leaves, the cassava leaves. But they would attribute it to physical factors such as the sun was too hot or other things, and would try and treat it with all sorts of remedies, even things like cow's milk.
In our engagement with farmers over time, we have realized that yes, they are very responsive to new things. But you need to continue working with them so that at some point you gradually pull out and allow them to go on their own, continue with the benefit.
I'm called Tom Omara. I'm a research officer. Well, I'm mostly engaged in field-based research, farmer capacity building. In capacity building, we involve training of farmers. Then we also engage so much in practical application of the trainings. For example, if we want to train farmers on good agronomic practices, cassava, common diseases and pests of cassava, what we do, we engage with the district agricultural and production officers in the different districts which we have interest in. When we talk to them, we request these officers at the district to organize and get for us good farmer groups which are blended with both women and men, so that we can come and interact with them.
I'm Kiria Peter. I'm the extension worker for Nankoma sub-county here in Bujiri district. I'm concerned with disseminating new technologies that I receive from research stations to our farmers. Then also, I have to update them with the challenges in the field that our farmers are facing. Way back in 2020, we had a challenge where almost all the cassava were wiped out in this area due to cassava mosaic and cassava brownstreak disease, which were brought about by the whiteflies. So these people came up with an intervention where we were dipping the cuttings in a chemical called imida before planting. And when we planted, also we sprayed twice those crops so that we could eliminate the whiteflies. We had several cassava varieties in our demos, and then we involved a lot of farmers. Farmers helped us to select which variety was very good in this locality, so I'm proud of that.
The farmer situation has changed enormously. When I first started working on cassava, there was food insecurity. Now there's all sorts of new disease-resistant genotypes that have been disseminated to farmers. The problem now really is that some of those disease-resistant genotypes are actually quite susceptible to the vector. So we have a situation where the cassava is resisting the disease but is unable to resist the vector. So the vector generates huge populations on some of these crops, and that's a very dangerous situation because the whiteflies also feed on wild host plants where they'll pick up new viruses which potentially could be transmitted to cassava, and that's what this last 8 years has been about. We really need to get a handle on tackling the whitefly vector, which is what we've done quite effectively.
Now that we have gotten a solution through science and together with the farmers who are the beneficiaries, and now they understand that the whitefly can be controlled by using resistant variety, which we have identified one with them in a participatory manner. The farmers also now know in the interim short term, you can use a systemic insecticide in a very judicious way and control this whitefly with enormous benefit. The next thing now to do is to roll out these two technologies widely beyond where the project operated. Because where the project operated, the farmers understand it and they seem to be comfortable. But one thing, knowing, understanding and being comfortable is good. So we need to encourage those who participated in establishing and finding out this solution so that they can outscale. But two, as a project, we need to use this same knowledge and go to other places where this was not done so that they can also have the same benefit, first, to understand it, then two, to quickly adopt it. So in other places, it will be a bit easier because we are going with a proven technology from science and from the farmer's perspective. So that's what we want to do now.
We've come a very long way from where we started in those very dark days where we really didn't know what needed to be done. So what comes next is the mid-term technologies that we're developing, and that's through our pre-breeding work. We've found genotypes in Latin America that are highly resistant to African cassava whitefly, and we've done some pre-breeding work to introgress those into a background that would be suitable for the climate here in Africa. We've already done some crosses with African material, and we're extremely optimistic that those genotypes will have a big impact if they're used on a landscape scale to control African cassava whiteflies. The other thing we're doing is exploring a biotechnological approach, and that's generating completely novel resistance mechanisms to combat what is, as I said earlier, an extremely formidable insect adversary. And hopefully with that type of arsenal to work with, we can effectively solve this problem for the foreseeable future.